So really quick today, I'm going to go over something called a test cross, or how do we identify an organism's genotype. So we've been doing all these genetics problems where we know the genotype of the two parents. We know that the dad is homozygous dominant and the mom is heterozygous or something of the sort. But that's not true in the real world. We can't just look at a person and know what their genes are. So we need to kind of develop a method for identifying an organism's genotype. And that's what we're going to go over today. How do we actually figure out what an organism's or what a parent's genotype is so we can predict their offspring? And modern day science can use like DNA tests to figure this out. But before that, we would actually have to mate two parents together and look at their children to identify what their genotype is. So that's kind of the process we're going to go over. It's called a test cross. So let's just start off with the basics. So for some organisms, we can figure out their genotype just by looking at the organism's phenotype. And what I mean by that is basically if you look at an organism and that organism shows the recessive trait, then you know that they must be homozygous recessive. So say, for example, we have two frogs and being spotted is dominant and being not spotted is recessive. If I see a frog that is not spotted, I know right away he must be homozygous recessive because the only way to be not spotted is to have two recessive alleles. If I had one dominant allele, I'd be spotted. So that's one way you can figure it out. If you see an organism that has the recessive trait, you know they must be homozygous recessive. What happens if we see an organism that shows the dominant trait? Well, if an organism shows the dominant trait, we know they can be one of two genotypes. They can either be homozygous dominant, two capital letters, or two dominant alleles, or heterozygous, one capital, one lowercase, one dominant allele, one recessive allele. And the reason why they can be these two things is because they both produce the dominant phenotype. So this is a scenario where we look at an organism, we see what he looks like, we know that he must have a dominant allele, but we can't be sure what his other allele is because both make him the dominant phenotype. So when we see an example like this, when we see an organism showing the dominant trait, to figure out what his actual genotype is, we do something called a test cross. And a test cross is when we take that unknown organism with a dominant allele, and we cross them with a homozygous recessive individual, and we look at their children. The reason why we use someone who's homozygous recessive is just like I said. We know someone who's homozygous recessive. We can see individuals with the recessive trait. We know they're two alleles. We know they're two lowercase alleles. So these are always our knowns. So that's why we're going to cross our unknown with someone who is known. So let's look at an example of what this might look like. And this is going to be a problem very similar to something that you're going to see. Let's say we have pea plants, and pea plant has a tall phenotype. We want to know if that tall phenotype is homozygous dominant or heterozygous. So in this scenario, tall is dominant and short is recessive. So I have a pea plant that is tall. But I don't know if it's homozygous dominant or heterozygous. So what I'm going to do is I'm going to take a short pea plant, which I know is little t, and I'm going to force it to have children with my unknown tall plant to figure out what his genotype is. So there's one of two things that can happen from our test cross. So we're going to force that unknown parent, let's say he's up here, to have children with a homozygous recessive individual, the short plant. The first scenario that could happen is every single child we get out of that cross could be tall. So if every single child that comes out of these two parents is tall, we can work backwards and figure out what our unknown parent was. Well, what must be the two letters? We know one's going to be a capital T because obviously that parent's tall. But what's the other letter? Well, if all the children are coming out tall, the way we make this square would be if we had two capital T's. So if all the children are tall, if all the children show the dominant trait, that means that our parent was homozygous dominant. However, if we go ahead and do this test cross, and we find that half of the children are tall, and then half of them come out short, well, we know, working backwards, the only way we can make a short person is with two little t's. So that other letter must be a little t. Our unknown parent is heterozygous. Now, it's important to note for this to work, you have to have lots and lots of children, because you need to be sure that all your offspring are turning out tall. Let's say we did this cross and we only had 3 babies, and 3 of them turned out tall and 1 of them turned out short. Well, that's very likely because remember, these are percentages. These don't mean every 4th child. So if one child turns out short, that's all we need to know to tell that our parent is heterozygous. So generally when scientists do test cross, they do hundreds and hundreds of children to get some accurate results and to make sure, okay, definitely all the children are coming out tall. We've had 100 babies. We haven't seen a short one. So they mostly do this with plants and stuff to kind of figure out what their kind of genotypes are. So that's a test cross.